Hey folks, it's Friday, and we have a little bit more to do in section 8.5. Here is what we did yesterday. I'm just going to do a recap. You can fast forward through this if you're like, I don't need any of that, Nelson. So let's say you had 3x minus 2y equals 18, okay? Step one is to set x equals 0. We're going to find the y-intercept by doing this, because if you're on the y-axis, the x is going nowhere. We're not going to the left, we're not going to the right, we're just going up or we're going down along the y-axis, right? So we're finding the y-intercept. So when I plug 0 in for x, 3 times 0 is 0. We were just saying yesterday that you end up with negative 2y equals 18. That's what you were supposed to put into one of those boxes on that Desmos classroom activity, is negative 2y equals 18. Then you solve for y by dividing both sides by negative 2, right? So divide by negative 2, divide by negative 2. Or you do a look inside technique. Negative 2 times what is 18? That should be negative 9, I think, right there, right? So we go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. And I'm just going to, I don't know, maybe this isn't important, but I'm just going to try to put a purple color right there. That is my y-intercept, right? All right, so if you plug 0 in for y, now we're finding the x-intercept, okay? Because if you don't go up or down on the y-axis, that would be y equals 0, then you're going to go either to the right or to the left, and that's what we're looking for, right? So when you plug y equals 0 right here, that's all gone, right? So you've got 3x equals 18. You divide both sides by 3. You get x equals 6. You go 1, 2, 3, 4, 5, 6. And I'm going to, hopefully I counted that right. 1, 2, 3, 4, 5, 6. Okay, yep. And I put a dot over there. Now we just need to connect those two dots with a line that would go on forever. Okay, so let's see here. If how can I do this here? I think I can grab the line. I want the line. I just want to extend it out in that direction forever. And I'll put little arrows on there because there was no domain restriction, no codomain. It's just a domain that's all real numbers, and the range is all real numbers. This is a one-to-one function. It's on to all that jazz, right? So my step 3 is just connect the two intercepts, right? We're going to come back to this when we change this to an inequality. So, boy, I haven't had my highlighter on in a long time. Let's see what happens if I highlight the equation, the equal sign. We're going to change that to an inequality. We'll see what happens here in a moment. First, let's talk about slope-intercept form. Okay, so here's slope-intercept form down here, and I'm going to give you an example, and we'll break it down into some steps. Sorry, I don't have it super neat over here. I'm going to do step 1, and I'm going to do step 2, just like before. I think there'll be a step 3. But they're a little different. We're not going to plug zeros in for x and y. We're going to look at the given information. Like, let's say we had y equals 2x plus 3, okay? This is our y-intercept right there. That's our y-intercept. Now, why is that true? Because if we stick 0 in for x, 2 times 0 is 0, that'd be all gone. We'd have y equals 3, right? So identify, I'm going to put down ID for identify. Probably shouldn't have put a dot there. Let me undo that. So we're going to ID the y-intercept, okay? That is the b value right there. That's our y-intercept. Okay, I'm going to write the whole word out over there, intercept, and I probably should do that over here too. Y-intercept, sorry about that. It's not super neat writing. So that is what, 0, 3, right? So I just go up 3 spots, 1, 2, 3, okay? And I put a dot on my y-axis. So that's step 1. Step 2 is to ID the slope. ID slope. Okay, where the heck is the slope? The m is a constant. It's a letter that's representing a constant known as the slope. Okay, so this guy right here is our slope. So slope equals 2. Okay, so that means that rise over run, which you guys remember is the slope, is equal to 2 over 1. That's, the same as 2, right? I'm going to make it look like a fraction so that we have a run going on. So we go up 2 That was kind of a geeky little laugh there, huh? I got a fraction here. Oh boy, I'm such a math nerd. So we go up 1, 2, and then we go over 1, right? So I go up 1, 2, over 1. That's my slope, right? I'm just trying to find another point. And so that's really what I'm doing here is when I d my slope, I'm going to find another point to graph, right? So maybe that's my step 3 is really using slope to find another point. So use slope to find second point, okay? And then you connect, them to make a line, right? Connect 2 points. Okay, 2 points make a line, right? So let me grab my line tool over here. And now my line tool, see, I got to really start here. Now, if you're drawing with a pen, I guess I could do that too. I could just kind of eyeball where I should go here. So I'm going to try that. Like I could go down 2, back 1, down 2, back 1, down 2. I don't know if I'm still in the ballpark here. I'm trying to get my line to go right through those 2 points. Okay. So then what I would do next is I'd put a couple arrows on the ends, like this, right? And now I've graphed my line. That's how you graph a line in slope-intercept form. Now, like I said, we're going to come back to this guy right up here, and we're going to change it to an inequality. So check this out. Concept, whatever you want to call it, concept number 3 is inequality. Let's put it right over here in our left column here, inequality. So what if this was not an equation, but an inequality like this? 3x minus 2y less than 18, okay? If it was an inequality like this, here's the next step. There's like a step 4. Well, maybe step 4 and 5, okay? Step 4 is, look, it's a less than sign. It's not a less than or equal to. I'm going to put an equal to down here for just a second. If it was equal to, I leave it as a solid line just like it is, but it wasn't an equal to. As you just saw a second ago, it is I'm going to push my picture off the screen there. It's just a less than sign right there, right? So I'm going to get rid of the solid line. Okay, so let me see here. I could get rid of the solid line by clicking on it, hit delete, and I'm going to change it to a dashed line. Okay, so let's go blue here just to kind of emphasize this. I'm going to dash my line because it's less than or greater than. If it was greater than 2, I would just dash it, okay? If there's no little bar underneath. If there's a bar underneath, keep the line solid because you want those points, because the bar underneath means or equal to. So now you're saying all the points that were on the line are good points. Like if this was selling gasoline and you go over to 7 gallons, you want that point that's on the line. If you go to 8 gallons, you want that point that's on the line if it's an equation. So by having the little bar underneath, we really have an inequality and an equation. That's why you're saying you want the solid line. Gosh, I hope I'm making that clear. That's a huge concept right there. Now, so step 4 is decide if you want solid or dashed. So solid or dashed line, dashed. And dash would be either a less than symbol or a greater than symbol. A solid would be a less than or equal to, and or greater than or equal to. Can't be both at the same time. So step 4 is, because I don't have room to make a step 5. And shade. Okay, I don't mean like disrespect this graph. I'm saying we're going to shade in a certain direction. Either we're going to go that way off the line or we're going to go that way off the line, shading, because we want all the points that satisfy this inequality. So what I love to do is if my line doesn't go through the origin, which it's missing the origin, here's the origin right over here. Okay, so I'm going to change to red here just so this really stands out. I love taking the origin if it's not on the line. Well, why do I do that? Because 0 is a super easy number to try out. So 3 times 0 minus 2 times 0. I'm plugging in. Let me make a little note of that. Plug in the origin if it's not on the line. If that line was going through the origin, then I can't take the origin. Then I take the next like maybe 1, 0, because 1 is easy to deal with also. So I take 0, 0, and I plug it into my inequality, and I got 3 times 0 minus 2 times 0. Is that less than 18? Well, yes, because 0 is less than 18. So let me just put that word over here. I haven't done that before in the past, but yes, I want that point. But you know what? If I would have tested out like 1, -1, that would have worked. If I would have tested out 1, 1, that would have worked. I mean, I could test out any point over here and it would have worked because this one works. So all of them work in that direction. So what we're going to do is we're going to shade in that direction. Now, I think I have a crayon down here or something like that. What is that guy right there? Maybe this is a crayon here. I'm gonna go pink color. Let's see if that's not the crayon. What the heck is that? Well, oh, it disappears. What the heck? Let me try again. Sorry, folks. I thought I had maybe it's this guy. Let's try this one. See what this one looks like. It's not a crayon, actually. I had a crayon in my other program. So you're shading, saying you want all these points in this direction, okay? Now, if it was a slope-intercept form line, you'd do the same exact thing. You would just graph the line first, okay? You got to do steps 1, 2, and 3. Step 4 is the one that is additional if you have an inequality, okay? So, man, I hope I'm making that clear. Let me just circle my inequality. See how it's different? It's different because it has like a less than sign right there. Okay. So you're going to see shading on inequality problems. Hey, thanks for watching my video today. Good luck with the homework.